Good morning, children. In this video, we should learn about the uses of cross section formula. What is the use of section formula? Before going to that, let us learn some concepts. Let us take intersection of two lines. Intersection of two lines. What is the mean of intersection of two lines? Suppose there are two lines, line L, line M. When we draw these two lines in this manner, these two lines have a common point. This is the common point for both the line L and M. Whenever two lines have a common point, then the lines are called as intersection or intersecting lines. Intersecting lines or lines are said to be intersecting. Then the common point is called as point of intersection. Point of intersection. If two lines have a common point, then the lines are said to be intersecting lines, and the common point is said to be point of intersection. For example, more than two lines. Suppose there is another line P and there is another line Q. There is another line R. So here these all are lines having common point. Here 1, 2, 3, 4, 5. More than two lines. More than two lines have a common point. Then these lines are said to be concurrent lines. Concurrent lines. And the common point is called as point of concurrent. Point of concurrent. If two lines have a common point, then the lines are called as intersecting lines, and more than two lines are having a common point, then the lines are said to be concurrent lines, and the point is nothing but a point of concurrence. Point of concurrent. How they will be in the triangles? So in the triangles, suppose if we take perpendicular bisectors of triangle, perpendicular bisectors of triangle, these perpendicular bisectors having a common point. So these perpendicular bisectors having a common point. So that means these are concurrent because more than two lines. So more than two lines, no, therefore concurrent. That means which are concurrent? Perpendicular bisectors of a triangle are concurrent. Perpendicular bisectors of a triangle are concurrent. Therefore, this point of intersection, this concurrent or point of concurrent point. Okay, point of concurrent is nothing but circumcenter. Circumcenter is clear. Point of concurrent of the perpendicular bisectors of the lines of the or sides of the triangle. Point of concurrence of the perpendicular bisectors of the sides of the triangle is nothing but circumcenter. Circumcenter. Suppose if we take a triangle like this, and taking a triangle. So let name it as ABC. I will take a midpoint of BC like D. Midpoint of BC is a D. So if I join midpoint of one line segment and its opposite vertex, we will get like line segment AD. So this line segment AD is called as median. What is median? The line segment joining of a midpoint of a side and its opposite vertex is called as median. How many medians we can draw? If we take midpoint of AC as E, so we can join AE, and if we take midpoint of AB as F, we can join FC. So what happened here also? There are three lines or line segments. What are these lines? These are medians. So these are more than two lines have a common point. That means medians have a common point. Therefore, these are concurrent. So which one are concurrent? Medians of a triangle are concurrent. Then what is the common point or what is the point of concurrence is? The point of concurrence of the medians of a triangle is named as centroid. It is denoted with capital letter G. Capital letter G. What is G? Centroid. What is centroid? The point of concurrence of the medians of a triangle is centroid. The point of concurrence of the medians of a triangle is called as a centroid. Therefore, this centroid divides this line segment. Means this is a point. This centroid divides the median in the ratio of 2:1. In the ratio of 2:1. Here also 2:1. That means this is 2%, this is 1%. This is 2%, this is 1%. So whatever the centroid divides the median always in the ratio of 2:1. 2:1. For example, this point is x1 by 1. This point is x2 by 2. This point is x3 by 3. Then how can we find centroid? So to find centroid, we must use the concept of section formula. Section formula means you suppose I want to find this G. I know the ratio what the point G dividing this AD. So using this ratio I can find this point when if we know point D. What is point D? Midpoint of BC. Can we find midpoint of BC? Yes. We have x2 by 2 and x3 by 3. So it is very easy to find midpoint of BC, that is D. So what is the midpoint of BC? It is clearly this plus this by 2, that means x2 plus x3 by 2 and y2 plus y3 by 2. So I have AD line segment. In that point G is dividing this AD in the ratio of 2:1. In the ratio of 2:1. So if point G is dividing the line segment AD in the ratio of 2:1, we can find easily whatever the point G, because it is dividing AD interiorly or internally. So here our line segment points are AD, that is x1 by 1 and x2 plus x3 by 2 and y2 plus y3 by 2. So by using these 2 points we can find G using section formula. What is section formula? Section formula already we just learned in the previous video. Let us recall. So m1 x2 plus m2 x1 by m1 plus m2, m1 y2 plus m2 y1 by m1 plus m2. So this is the formula. Whenever A, B and P dividing in the ratio of m1 is to m2, then the coordinates of P is m1 x2 plus m2 x1 by m1 plus m2, m1 by 2 plus m2 by 1 by m1 plus m2. So using this section formula, how can you find centroid. So here what is the endpoints of the line segment AD? A is x1 y1, D x2 plus x3 by 2, y2 plus y3 by 2, and the ratio m1 is to m2 is equal to 2 is to 1. So what is G? G, I will write the formula m1 x2 plus m2 x1 by m1 plus m2, m1 y2 plus m2 y1 by m1 plus m2. Here m1 value is 2, x1 y1, x2 y2. So what is the m1? M1 is 2 times of x2. x2 means this one, that is x2 plus x3 by 2 plus 1 into x1 by m1 plus m2, and here also same 2 into y2 plus y3 by 2 plus 1 into y3 by 2 plus 1. These two gets cancelled. Remaining is x2 plus x3 plus x1 by 3, and this is also we can terminate this to 2. So y2 plus y3 plus this is y1 by 3. So what is this x2 plus x3 plus x1 by 3 and y2 plus y3 plus y1 by 3 means G. So simply the G you can write it as x1 plus x2 plus x3 by 3, x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So this is the centroid of a triangle when 3 vertices are given. So x1 y1, x2 y2, x3 y3 are the 3 vertices. Then centroid of a triangle ABC is equal to x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. So this is the formula for the centroid. Centroid is nothing but the point of concurrence of the medians of a triangle. Let us take one example. Find the centroid of a triangle whose vertices are order pair -4, 6, order pair 2, -2, and order pair 2, 5 respectively. So how do we find the centroid of the triangle when vertices are given? Suppose A, it is -2 order pair -4, 6, and B order pair 2, -2, C order pair 2, 5. So it is clearly we have the centroid G is nothing but x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. So if this is x1 y1 and x2 y2 and x3 by 3, then you get G is nothing but -4 plus 2 plus 2 by 3, comma 6 plus or minus is -2 and plus 5 by 3. So it is nothing but -4 and +4. It is nothing but 0 by 3, and this is 6 plus 5 is 11. 11 minus 2 is 9. 9 by 3. So it is 0 by anything is 0, and 9 by 3 is nothing but 3. So this is a simple, and the centroid is 0, 3. The centroid of the triangle whose vertices order pair -4, 6, order pair 2, -2, and order pair 2, 5 means centroid is order pair 0, 3. Children, let us take the questions from exercise 7.2. In that the question third one is the first question, second question you can do easily because asking the point internally. Now the question 3, find the ratio. Find the ratio in which the line segment joining the points order pair -3, 10, and outer pair 6 comma negative 8 is divided by outer pair negative 1 comma 6. So it is clearly mentioned line segment joining 2 points are one is A, that is negative 3 comma 10, and B is 6 comma negative 8. And there is a point, this point P, which is dividing. What is this point? Outer pair negative 1 comma 6 in the ratio m1 is to m2. That means we should find this ratio. Is asking ratio, find the ratio. In the first question, second question asked the point by given ratio, but here given point and asking the ratio. So we know it. What is the point here? A is negative 3 comma 10, B is 6 comma negative 8, and the point P is negative 1 comma 6. We know it, section formula. P is nothing but m1 x2 plus m2 x1 by m1 plus m2 comma m1 y2 plus m2 y1 by m1 plus m2. So this is the section formula already we discussed. So what is P here? P is negative 1 comma 6. So it is nothing but we can take m1 x2 plus m2 x. Okay, substitute what are that? m2. What is that one? We don't know. m1 x2 is 6 plus m2 into minus 3 by m1 plus m2, and whatever m1 into y2 is into 8 plus m2 into 10 by m1 plus m2. So this is just for understanding purpose I am taking these 2 points. Actually no need to take the 2 points. 1 point is enough. Suppose if we have taken, I mean what the mean of this set, negative 1 is nothing but this one and 6 is nothing but this one. That means negative 1 is the x coordinate, 6 is the y coordinate. So it is clearly negative 1 is nothing but 6m1 minus 3m2 by m1 plus m2. So after cross multiplication we will get negative 1 into m1 plus m2 is nothing but 6m1 minus 3m2. So this is negative m1 negative m2 is equal to 6m1 minus 3m2. So to make the possibility, I will take 6m1, negative m1 comes this side plus 1m1, and minus 3m2 goes that side. This is 3m2 minus m2. So you will get 2m2, which is equal to 7m1. Now you can make m1 and m2 here means, so you get 2 by 7. Therefore m1 is to m2 is nothing but 2 is to 7. Therefore m1 is to m2 is nothing but 2 is to 7. 2 is to 7. So like that we can find the ratio also if the point is given. The point is given. Okay children, now the question is fourth question. What is the fourth question? If for order pair 1 comma 2, order pair 4 comma 5, order pair x comma 6 and order pair 3 comma 5 are vertices of the parallelogram taken in order, find x and y. Find x and y. So these are all taken in order, means A, B, C, D. What is the parallelogram? This is the parallelogram. So A, B, C, D. So in this A is order pair 1 comma 2. This is 4 comma y. C x comma 6 and D 3 comma 5. 3 comma 5. So how can we find the x value and the y value? We know it. The properties of parallelogram. What are the properties of parallelogram? Opposite sides are parallel and equal. Diagonals are bisect each other. diagonals are not equal, opposite angles are equal, adjacent angle sum is supplementary. These are the properties. In that second property, diagonals bisect each other. Means if we draw diagonals A and C and D and B, they mutually bisect each other. This measure is equal to this one, this measure is equal to this one. Means suppose this point if you have taken, this is the common point of both AC and BD. That means this point is the midpoint of AC as well as midpoint of BD. That means midpoint of AC is same as the midpoint of DB. If we take that condition, what is the condition? Midpoint of AC and the midpoint of BD. If you have taken, both are equal. So A and C. This is A and C. That means what is the midpoint? X1 plus x2 by 2 and y1 plus y2 by 2. That means here 1 plus x by 2 and 2 plus 6 by 2 is equal to, this midpoint is 3 plus 4 by 2, 5 plus y by 2. So 1 plus x by 2 is equal to this x coordinate, that is 3 plus 4 by 2. It means 7 by 2 is equal to 1 plus x by 2. 2 gets cancelled. 1 plus x is equal to 7. So x is nothing but 7 minus 1. It is 6. X is equal to 6. In the same way, if we have equated y coordinates, that is 2 plus 6 by 2 is equal to 5 plus y by 2. That means 2 gets cancelled. This is 8 is equal to 5 plus y. So 8 minus 5 is nothing but y. So 3 is equal to y. 3 is equal to y. So here x is equal to 6 and y is equal to 3. So by this way we can find x value as well as y value when this one is. In some cases what happened, they ask trisection points of line segment AB. What is the meaning of trisection points of AB? Trisection points of AB means that line segment AB we are dividing into 3 equal parts. So by how? By taking 2 more points. Suppose P, Q are 2 points, then this AP is equal to PQ is equal to QB. That means this point is equal to this one is equal to this one. Suppose suppose the endpoints are given x1 by 1, x2 by 2. So these are the trisection of the line segment. P and Q are trisection points of the line segment AB. So how do we find P? Already AP is equal to PQ is equal to QB. That condition we know it. That means this is equal to this is equal to this one. So there are 3 equal parts. So to find P, what ratio we can be taking to find P? M1 is to M2 can we take it as 1 is to sum, that is 1 plus 2, that is 1 is to 2. To find Q, here to get parts are 2 parts. So M1 is to M2 is 2 is to 1. By taking these ratios to find P, M1 is to M2 ratio is 1 is to 2. To find Q, M1 is to M2 ratio is 2 is to 1 I have taken. Then we can find P value and Q value, so that PQ divides the given line segment in 3 equal parts. That is called as a trisection. 4 parts means we will get the same thing only. Then we get 3 parts, that is P, Q, R. So 1 is to 3, 2 is to 2 and 3 is to 1. By the way, we will find the 4 parts. So by that way you can complete the exercise 2. If you are not getting, just post to me, I will explain it again.